everyone, how are you today? I'm teacher Saraswati from IPG campus, Pulau Pinang. Today, we are going to learn topic 10 for Form 2 Mathematics, which is gradient of a straight line. Before we go into the topics, let's look at the learning objectives for today's lesson. First, we will define the slope or the gradient of a straight line. And then, we will find the gradient of lines, including horizontal and vertical lines. And finally, solve problems involving gradients. Now, where have you seen the application of gradient in your real-life situations? Can you recognize any one of it? Let's see. Have you ever tried the Penang Hill cable car? Do you enjoy them? Do you know that the steepness of the cable car tracks can be represented using gradient? Look at the picture above. This amazing view was taken at Jalan Kimanis Keningau in Sabah. The road in this picture also can be represented using gradient. So, if you really look around you, there are many situations where the knowledge of gradient can be implemented. Then, what is exactly a gradient? There are few ways to define gradient. First, gradient is a value of the steepness of a straight line. Gradient is often referred to as the slope of the line. For example, like the path the car uses to move from A to B. Gradient of a straight line is also the rate at which the line rises or falls vertically for every unit run or across to the right. You can observe this from the diagram where the rise represents the changes vertically and run for the horizontal changes. The gradient of a straight line is also the ratio of vertical distance to horizontal distance. The vertical distance is the changes in y, and the horizontal distance is the changes in x. In mathematics, we state the gradient of a straight line with notation m. So, the gradient, or m, equals the vertical distance divided by the horizontal distance. Now, let's try some simple questions for your better understanding. Question 1. Find the gradient of the straight line C. How are we going to find the solution? From the diagram, we can find the vertical distance of the line, which is 3 units. From the diagram, we can find the vertical distance of the line, which is 3 units, and the horizontal distance would be 4 units. Using the formula of ratio, m equals to 3 over 4. That's the gradient of line C. Simple, isn't it? Let's continue further. Question 2. Find the gradient of the stair AB. Again, from the diagram, we can find the vertical distance of the line, which is 8, and horizontal distance would be 10. Using the formula of ratio, m equals to 8 over 10, and we simplify it to 4 over 5. The gradient is 4 over 5. Now, let's try this on your own. A simple question just to test your understanding. Question 3. Find the gradient of the stair AB. Alright, let's check your answer. We know the vertical distance to be 16 and horizontal distance to be 24. So, by using the formula, m is equals to 16 over 24, and we simplify it to 2 over 3. Well done! Another simple question to test your understanding. Question 4. Find the gradient of the straight line AB. Come on, do it yourself. I'm sure you can do it. Alright, let's check your answers. Using the formula of ratio, we will get m equals to 9/5. Simple, right? Well done, everyone. Next, we are going to find the formula to calculate the gradient of a straight line on the Cartesian plane. Previously, we have seen that the gradient of a straight line is the ratio of the vertical distance to the horizontal distance. In this diagram, the vertical distance is the difference between the y coordinates, y2 minus y1. And the horizontal distance is the difference between the x coordinates, x2 minus x1. Now, we can substitute the vertical and the horizontal distance into the formula. And we will have m equals to change in y divided by change in x. Another way of determining the gradient is using the intercepts. X-intercept is the intersection between the straight line and the x-axis. And y-intercept is the intersection between the straight line and the y-axis. M equals to y minus 0 divided by 0 minus x. M equals to y over negative x, and finally, we can conclude m equals to negative y-intercept divided by x-intercept. Finally, on the Cartesian coordinate system, the gradient of a straight line that passes through the 2 points A, x1, y1, and B, x2, y2 can be calculated by using m equals to y2 minus y1 over x2 minus x1, or m equals to negative y-intercept over x-intercept. Question 5. Find the gradient of a straight line passing through two different points A, 0, 0 and B, 2, 6. So, first, we need to determine the value of x and y. From the question, we can state that x1 equals to 0, x2 equals to 0, y1 equals to 2, and y2 equals to 6. Using the formula of gradient, m equals to 6 minus 0 over 2 minus 0. Simplified to 6 over 2, and finally, the gradient would be 3. Another question. Question 6. Find the gradient of a straight line passing through point A, 2, 3 and B, 5, 9. Just like the previous question, we need to determine the value of x1, y1 and x2, y2. Then, by using the formula of gradient, m equals to 9 minus 3 over 5 minus 2. Simplified to 6 over 3, and finally, the gradient would be 2. Easy, isn't it? I'm sure all of you can do this. Question 7. Find the gradient of the straight line below. From the graph, we can see that there are 2 points, which are 4, 8 and the origin, which is 0, 0. By substituting both points into the formula of gradient, we will get 8 minus 0 over 4 minus 0. And finally, after simplifying, the gradient of the straight line would be 2. Question 8. Find the gradient of the straight line below. From the graph, again, we can see that there are 2 points, 0, 6, which is the y-intercept, and negative 4, 0, the x-intercept. As both points are intercepts of x and y-axis, we can use the formula of intercepts, which is negative y-intercept divided by x-intercept. Now, by substituting both points into the formula, we will get negative 6 over negative 4. And simplifying, the gradient of the straight line is 3 over 2. Next question. Question 9. Find the gradient of the straight line joining the points P and Q. From the graph, we can see that there are 2 points, negative 4, 5, and 4, 17. So, first, you need to determine the value of x and y. From this point, we can state that x1 equals to negative 4, x2 equals to 4, y1 equals to 5, and y2 equals to 17. Now, substituting both points into the formula, we will have m equals to 17 minus 5 divided by 4 minus negative 4. And finally, the gradient of the straight line is 3 over 2. Now, try this on your own. Question 10. Find the gradient of the straight line below. Come, do this first. By substituting both points into the formula, we will get 7 minus 1 over 3 minus negative 1. And finally, after simplification, the gradient of the straight line would be 3 over 2. Did you get it? Well done! Those of you who didn't get it, don't worry, you can always try again. Alright, another question for you. Question 11. It is given that OE to OF equals to 4 over 3. Find the gradient of the straight line below. Come, do this first. Right? Let's check your answers. By substituting both points into the formula, the gradient of the straight line would be negative 4 over 3. Well done! Let's make generalization for the gradient of the straight line. Imagine walking up a set of stairs. Each step has the same height, and for each time you move, you can only take one step forward. If the steps are taller, you will reach the top of the stairs quicker. If each step is shorter, you will reach the top of the stairs more slowly. Confusing? Alright, let's have a look at sets of stairs to understand this better. There are 3 sets of stairs with red, blue, and green arrows. Notice that the blue arrow is steeper than the red arrow, and the green arrow is shallower than the red arrow. From your observation, you can see that the blue steps are taller than the red steps, so the gradient is steeper. The green steps are not as tall as the red steps, so the gradient is shallower. And the gradient formula of a straight line shows us how steep the arrow is. Look at the diagram and observe its gradient. line A has a gradient of 2, line B with 1 gradient, and line C which has 1 over 3. From our observation, the gradient of line A is larger than line B and line C. How about the steepness of each line? Line A has a gradient of 2, line B with gradient of 1, and line C with gradient of 1 over 3. From our observation, the gradient of line A is greater than line B and C. How about the steepness of each line? Again, look at the diagram. We can observe that steepness of line A is greater than line B and C. Based on the diagram, you can see that the purple line has greater slope compared to yellow and red line. Also, the purple line is steeper than the rest of the line too. From this, we can conclude that the greater the gradient value, the steeper the slope of the straight line. Gradient also can be either positive or negative. The direction of the slope is also determined by the negative or positive value of the gradient. For a positive gradient, the line faces upwards, moving from the bottom to top. For the negative value of gradient, the line faces downwards or move from top to down. For the negative value of gradient, the line faces downwards or move from top to bottom. In order to find the gradient of a straight line, how far apart do the coordinates we choose need to be? Look at this diagram and observe all 3 lines A, B, and C. Which one is the correct way of choosing 2 points? What do you think? Let's try to calculate the gradient for each line. For line A, by using the formula of ratio, m equals to 2 over 1 equals to 2. For line A, use the formula of ratio, m equals to 2 over 1 equals to 2. For line B, m equals to 6 over 3 equals to 2. And for line C, m equals to 10 over 5 equals to 2. So, by calculation, we obtain the gradient of A equals to B equals to C, which is 2. Then, we will make a generalization that the gradient of 2 points along the same straight line will be equal regardless of its distance between them. And what will happen if we move across? For example, riding a bicycle along a road. Will we be able to find the gradient? What do you think? Look at this diagram. This is a line which is parallel to the x-axis. Try using the ratio formula and find the gradient. The gradient is m equals to 0 over 5 equals to 0. Conclusion: a line that goes straight across along the horizontal line or parallel to the x-axis has a gradient of 0. Look at another diagram with a line parallel to the y-axis. Try using the ratio formula again. The gradient is m equals to 3 over 0 and it's undefined. Conclusion: a line that goes straight up or down along the vertical line or parallel to the y-axis is undefined because we cannot divide a number with 0. Next, we are going to solve problems involving gradient of a straight line. Find the value of k given that the gradient is 2 over 3. Find the value of k given that the gradient is 2 over 3. To solve this, first, you must remember the relation between gradient and points. Then, by using the gradient formula, we will get 2 over 3 equals to negative 4 over k. By calculation, 2k equals to 12. And finally, k equals to 6. Question 13. PQR is a straight line. Find the value of n. As all 3 points of PQR are on the same straight line, we know that the gradient of PR equals the gradient of PQ. So, use the points in the formula of gradient and calculate the value of n. And finally, the gradient will be 2. Now, try this on your own. Question 14. Find the value of k given that the gradient is negative 3 over 2. Do this first and we will discuss the answer in a while. Alright, with calculation, you will get k equals to negative 9. Well done to those who got it correct. To the others, you can try one more question. We are going to solve gradient problems involving real-life situations. The graph relates of y megabytes remaining to download to x seconds. Find the rate of change of the graph. Here, you need to understand that the rate of change of the graph is the gradient of the straight line. Both carry the same meaning. Now, from the graph, we have 2 different points, which is 0, 32 and 30, 86. Then, by substituting both points into the formula, we will get 86 minus 32 over 30 minus 0. And finally, after simplifying, the gradient of the straight line would be 9 over 5. Now, do this question on your own. The graph relates temperature Y degree Fahrenheit to altitude X in thousands of feet. Find the gradient of the straight line. You can look at the graph and get the important informations. From the graph, we have 2 different points, which is 0.59 and 7.33.8. Then, by substituting both points into the formula, we will get 59 minus 33.8 over 0 minus 7. Then, m equals to 25.2 divided by negative 7. And finally, the gradient of the straight line would be negative 3.6. In conclusion, gradient value is the steepness of a straight line. The gradient of a straight line is the ratio of vertical distance to horizontal distance. That's all for today. Thank you and see you all again. Bye!